Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Diana binti Jamalul. My matrix number CN240128. I'm a group leader of Group 4 for Section 2 Soil Mechanics. So basically, our group chose Group 4 Pulau Andaman, Pulau Pinang for our site project. I will present about the introduction of our group project. So the construction of basement structures play a vital role in modern building developments, providing essential spaces for parking, utilities, and storage. However, because of their subterranean location, basement constructions are constantly subject to environmental factors, groundwater influence, and soil pressure, all of which will have an impact on their long-term performance.
Hi, my name is Nukaija binti Muhammad Zainuddin. So I will explain about the engineering principle and the case study inside. So for our project at Pulau Andaman, the cracking slab and the retaining wall is governed by two main geotechnical factors. The first one is hydrostatic and tidal pressure. Being a coastal site, the tidal cycle is increased pore water pressure, creating a massive output buoyancy uplift. And the second one is consolidation and settlement. The structure rests on highly compressible bearing flow. So for our case study, we choose the Berjaya Times Square, where the field data show the groundwater drawdown can expand the ground sentiment. This is out 5 to 12 times the excavation depth.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sari, and I will presenting about failure mechanism and conceptual solution framework. So the headline cracks observed at basement 1 were caused by early plastic and drying shrinkage. This happened because the concrete was not cured sufficiently after the initial pour, combined with severe indoor temperature swings. Since our project is located at a coastal reclamation site in Pulau Andaman, these tiny cracks are highly critical. If we leave them untreated, they will act as open capillary channels, allowing the high groundwater and extreme ambient humidity to seep in and eventually rust dusty reinforcement. Looking at the soil structure interaction, we have to analyze how the surrounding environment affects the cracked concrete. As coastal groundwater constantly seeps through this initial shrinkage pathway, it penetrates deep into the concrete's internal air voids. This persistent moisture interaction accelerates the leaching and dissolution of calcium hydroxide, which rapidly strips away the concrete's natural alkalinity. Once this local alkalinity is lost, the protective chemical preservation layer around the embedded steel is destroyed, triggering progressive long-term structural leaching. So last but not least, to mitigate this, our conceptual strategy focused on a sustainable combination of localized repair and systemic restore methods, completely avoiding costly structural replacement. For superficial micro features, we apply a polymer surface seal to block out moisture. For deeper cracks, we implement a pressure-driven epoxy injection. We specifically select a low viscosity resin because, as proven in engineering literature by Griffin, material viscosity is the most critical factor for deep penetration and interfacial bonding. So their flexural testing demonstrated that a tailored low viscosity epoxy can successfully restore up to 84% of the concrete's original load-bearing capacity, safely recovering the slab structural stiffness.
Assalamualaikum. I will explain this slide. For this slide, we evaluated the engineering development, innovation, and technical aspect of the project. From the engineering perspective, we apply structure analysis and digital technologies such as Plexis, GeoStudio, and Midas Civil to ensure the design is accurate, safe, and reliable. This tool helps us analyze soil pressure, structural stability, and the performance of the retaining wall. Next, in terms of innovation development, the project focused on durability, waterproofing, and long-term structural ability. The use of waterproof protective coating helps prevent groundwater leakage, while continuous crack monitoring ensures the structure remains safe and stable over time. In addition, the innovation opportunity analysis shows that this project has strong commercial potential because it uses durable materials and requires minimal maintenance. The technology applied can also improve construction quality and provide long-term benefit to the construction industry. In conclusion, the engineering techniques and innovative solutions implemented in this project not only enhance structural safety and efficiency, but also contribute positively in terms of cost effectiveness, quality, and sustainability.
Today my name is Jerusri Anonymous. Today I will explain about implementation, conflict management, and system integration. The first step is to conduct a detailed site investigation to assess the soil properties, groundwater condition, and extent of the retaining wall failure. The information obtained from this investigation will be used to develop an appropriate implementation grouting design based on the actual site condition. Next, key design parameters such as the suitable grout type, injection pressure, spacing of injection point, and treatment depth will be determined. Issues and non-technical issues. First point is residents. Residents are mainly concerned about noise, dust, vibration, and traffic disruption during the construction work. They expect a safe and comfortable living environment with minimal environmental impact. However, some temporary inconvenience may occur during the grouting and rehabilitation activities. Second point is consultant. The consultant is responsible for ensuring the retaining wall remains safe and complies with engineering standards. They must develop an effective grouting design based on site investigation, result, and carry out the necessary testing and monitoring. One of the main challenges is balancing safety, project cost, and construction time while coordinating with the contractor.
For the conclusion of our project, basically, Plot 4 Pulau Andaman is significantly intensive by the challenging condition of its coastal reclamation environment. Elevated groundwater level and tidal fluctuations impose considerable hydrostatic pressure and beyond sea uplift on substructure, necessitating a critical factor of safety (FOS) of at least 1.2 to avert hydraulic heaving and structural fracture at fixed joints. Moreover, since retaining walls function within a limited strength range where soil stiffness experiences a sharp decline, lateral movement induced by excavation and unregulated groundwater extraction can lead into differential settlement that may cause the concrete to separate. That's all from us. Thank you so much.